Good evening to everybody. And so I just I shouldn't have done. I think that's okay. It's great to be here in South Africa, and it's my first visit here, and it's really wonderful to actually get to meet so many engineers here and to have had the opportunity to meet students as well, and obviously yourselves who are joining by virtual link this evening. So the title of what I'm meant to be speaking about is learning through conservation and preservation of historic structures. You may find I digress a bit because I get quite involved with the case studies which I've included within this. The picture that you're seeing on your screen at the moment, I'm actually not going to be talking about, but it's just such a great little building. It's a deer shelter in the northwest of England, which was actually built really as a vanity project because the deer don't need a building to go and shelter in. There are plenty of trees around, but the owner of the mansion built this thing to really show how much money he'd got and that he was able to. And it's much bigger than a lot of his workers' cottages. But the reason that I've been involved with this is that rabbits had burrowed underneath it and it's become quite unstable. The previous engineer had actually had a go at stabilising it and they'd underpinned it. Unfortunately, the rabbits have been back in and they've burrowed down and underneath and around the underpinning. And we now need to do a further ground improvement. And what we're looking to do is to inject the ground with a geopolymer, which I understand that the rabbits won't find attractive. At least that's what we're hoping. Anyway, moving on with the presentation. Hopefully, if I hit this one, am I going to get the... Great. Okay, so first and foremost, in my view, if you're going to learn, you've got to be prepared to be led and to follow and to listen. It's really, there's so much you can't learn just from books. There's a lot you can, but books and technical papers, they give you a lot of information, but we need to also be careful about the reliability of the source of information. The internet, very good, so long as you know that the source is reliable. But the most valuable to me has been people. So over the years, I've chosen to listen to as many people as I can, whether they're acknowledged specialists of their field or site staff, and actually the operatives have been really helpful. So as a young engineer, I had to do my year out on site, and the site team were just so helpful, really. Helpful, that's a good question. It might have been helpful in terms of their frustrations at the when they're being asked to fix reinforcement that's been detailed by somebody who didn't understand about really enough about bar bending, that you don't get a nice square corner at the of a link. You've got to have the curve, the radius on it, and so bars don't necessarily fit. But it's that kind of information that you really begin to learn when you work on site. So I started working on old and historic buildings early in my career, more by accident than design. And it was when I was working for Arup in the very early days that I got to work on the two buildings that you see on this slide. The top one, as you can read, is a Great Northern Railways goods warehouse. And it was whilst I was working on this that I started meeting terms like brick jack arches and fish belly beams and hogback beams. The names really describe what they are. The fish belly beam has a, as it were, a bulge on the underside. The hogback is a bulge on the top. It's so that the section is increased where the moment is going to be greatest. It was also while I was working on these buildings that I started to become particularly aware of cast iron and wrought iron. I mean, at university, we'd learned about steel, we'd learned about concrete. We didn't really touch on masonry. In fact, we didn't touch on masonry at all at university back then, and timber very, very peripherally. but the cast iron and wrought iron, they were completely new to me. So I'd started work in Manchester, looking at these two buildings, and the next company I worked with also did a lot of churches and a lot of conversion work on the cotton mills and weaving sheds which are prevalent in that part of the country. They dated from when the cotton trade was very active in the Manchester region, which was from about the mid-18th century through to the early 20th century. And there were so many buildings in and around Manchester that were related to that trade. The building where I started work was St James's building in Manchester. This shows just half of the front elevation. It's too big. You actually can't get at an angle where you can take a picture of the whole of the elevation. This was actually built in the late 1800s as a packing warehouse for the Calico Printers Association. It's a concrete and steel framed Baroque facade of Portland stone, which faces out onto the street, as you see. But at the rear of the building, looking at this Google view of it, you can see that the rear of the main elevation, which is facing southwest on your picture there, that the rear is much more functional. It's got light wells. Manchester's not the brightest, sunniest of places. And the light wells at each floor level, you would have glazing from ceiling down to approximately 1200 millimeters above floor level. So that was all glazed, so you got the optimum light in. And between the levels of glazing, you had white glazed brick, which bounced even more light back into the building. So it's a very practical way of getting light into the building for the people who are working in there. But what was particularly interesting for us as engineers working in there was that there were large, very wide window ledges, which had actually been designed for them to lay out the fabric so they could unroll the fabric and see the quality of the printing, so that it could be used as a marketplace really for selling the fabric. As engineers, it was actually fantastic because you could lay out AO drawings on this. Anybody who doesn't know how big an AO drawing is, it's twice the size of A1, which in turn is twice the size of A2, which is twice the size of A3. So you can work that one backwards up to the size of AOs. A lot of that's nothing to do with engineering, but it's just that taking the interest in the buildings. One of the particularly fascinating ones that I did work on, so it wasn't the building that was fascinating, it was the process that was fascinating, where they made the fabric for fleece jackets and fleece jumpers. And after I'd looked at an extremely boring little steel portal shed, which is what I was there to look at, the building owner offered to show me around the process that went on in the building. And I'll never forget that. It was so interesting just seeing how this fabric is made. And we have that opportunity as structural engineers to look at not just the building itself, but the process that goes on within that building. So as I worked on historic buildings, I began to recognise that there were typical features of these buildings, and most importantly, there were common features which may have affected the behaviour of the buildings. For example, in a weaving shed or a spinning shed, you'd have a drive shaft. So you'd have the engine house at one point in the building, and then there'll be a drive shaft which would drive all of the looms or the spinning machines. And what this tended to do was to pull all of the columns. They would have been a cast iron. It pulled them over, so they all, instead of being nice vertical columns, they would rack across to one side. And you'd look down the line of the building, and all the columns would be racking over. But in fact, it wasn't something to worry about, unless loads were being put onto them in the future, where the eccentricity could be a problem. So as I mentioned, I also spent a lot of time in the early 1990s working on church buildings. And these varied from very old buildings to moderately recent ones. started learning about timber frame buildings and about the different styles of masonry, from rubble-filled walls, which have a, I don't know if you get them over here, but you have a skin of masonry inside and out, and in between you've got really rubble stone in there. They're great until the rubble starts moving, and as soon as it loosens, the outer leaves of the wall can start bulging and the stability is lost. In addition to that type of information, you've got regional variations, local variations. And you also get to know how and when these types of structure will fail. But most importantly, you also learn about what to do about them and how to repair such damage. I went out to the Caribbean regional group earlier this year, and it was fascinating to see that some of the techniques that I've been using in the UK, they certainly weren't appropriate in that part of the world, in large part due to the seismic activity. So it would be a case of really picking the repair methods and techniques which are appropriate for whereabouts in the country the building is. I currently work for a company called Thomasons. We're consulting engineers, medium size, and we're based in Manchester. You may have gathered a bit of a theme of Manchester from the pictures so far. I've been with them for nearly 20 years now, and I've had the pleasure, whilst I've been there, building up the expertise of working with historic buildings. So I'm going to indulge myself with talking to you this evening about a couple of projects, quite varied in their scope. The first of which is one of my favourites. It's Wentworth Castle Conservatory. It's a Grade 2 star listed Victorian construction set in Parkland near Barnsley, up in the north of England. Now, what you see on the screen here was a photograph which had been taken and sent to somebody, goodness knows who, as a postcard. But we're so fortunate that this photograph existed because it gives us a huge amount of information, albeit that it's not the best of quality. But when you delve into it, there is a lot of information there which helped us with the reconstruction. The conservatory is approximately 25 metres long by 12 metres front to back, and it comprises 3 parallel bays with 2 rows of internal cast iron columns which support the roof structure. The primary structure of the conservatory, as I said, is cast iron for the columns and for the ring beams and the gutters, and then wrought iron for the glazing bars and some of the tie rods. When we arrived initially, the structure wasn't very obvious. This was the first sight of it I had, taken from the roof of the mansion to which it was attached, or had been attached. The walkway from between the conservatory and the mansion had long since gone by the time I arrived there. At this stage, you can see from the photograph, the conservatory was in a poor state. It was on the buildings at risk register, which was actually quite fortuitous for it because that meant it attracted some funding, and so there was some money available to undertake repairs. The entire frame when we arrived was supported on a scaffold structure, which was massively overgrown. You can see the growth coming out through the roof here. And if you see on the left-hand side of the picture, there's some tall conifers there. If we were to go back to that previous picture, which I think I can do, see they're quite small actually in this photograph. But by the time we got there, they were towering way above the conservatory. And when they were planted, they'd have been obviously even smaller. Perhaps whoever had planted them hadn't thought through quite how large it would have grown. Now, as the conservatory was still substantially glazed, the internal condition survey had to be, sorry, we had to undertake it wearing Kevlar suits. There was broken glazing and there was loose glazing. The Kevlar suits were hot, ill-fitting, extremely unattractive. Not that that matters at all, but they were cumbersome and awkward to work in. And this was in, I think it was June of the year that we did the survey, approximately 14 years ago. We had the pleasure, as you can see from this photograph, it was actually quite sunny, and it can be quite warm at times in England, and it was that summer. At the back of the building, which is to the right-hand side of the photograph that you're seeing here, there was a large, substantial sandstone wall, and the glazed structure was built up against that. Now, we were fortunate that there was a set of drawings which had been prepared by a previous design team, and we were able to use these as a basis for our survey. We inspected every single member that we could gain access to and decided whether it was possible to reuse it. Everything that you see coloured in red was beyond repair, and that was primarily all of the columns and quite a number of the members of the ring beam. Now, the reason that the columns were unusable was because the rainwater outlets from the valleys were blocked. The actual rainwater, the orifice in the valley discharging into the from the gutter into the column was a diameter of approximately 35 to 40 millimeters. And you can see with all the vegetation, and imagine the leaf litter and the debris that had collected in there, it was way too small. The columns had filled with leaf litter, with debris, and then water had gradually percolated its way through. But there was no means, there was no rodding at the bottom, so there was no means of actually cleaning out the columns. The rainwater collection system was interesting. It went to a below ground system. We knew that there had been talk of there being a rainwater harvesting tank, and we searched everywhere. We couldn't find it. We eventually managed to get a camera down along the drains underneath the conservatory, and we found they were open jointed. So we got to the stage of thinking, well, open jointed, a bit like a land drain, but instead of draining from the land, it was to allow the water to discharge out into the ground below the conservatory, which in turn would help to water the vegetation, the planting within the conservatory. So we gave up on looking for the rainwater tank. Once we actually started working and we started doing the new drainage for the development, we were putting a new visitor centre next to, on the far side of the stone wall that I mentioned before. And as we were excavating for that, there was a manhole cover was exposed. It had been buried under, again, years and years of leaf litter. We took that up and looked in, and there was a brick shaft. It shone a torch down into it, and there was a large, and this would have been approximately, probably about 3 metre diameter brick tank there. We couldn't get into it. It was a confined space, and there was water in the bottom. We didn't know how deep it was. We didn't know what the condition was. So, being a bit resourceful, without the necessary equipment, designated equipment, we took my camera, taped it to a wooden post, set the video function running on it, lowered it down into the shaft, and turned it around. I think we must have had a torch on there as well, actually, now as I think about it, because it actually gave us an extremely good impression of the condition of the rainwater harvesting tank, which turned out to be brilliant. We didn't need to do anything to it, and we could reuse it in the new drainage scheme. So, with the water having collected in the columns, what had happened was that we then had frost, and the water had expanded as it froze, and it had burst the columns so that we had a vertical splitting of the columns. Somebody tried to repair them. It had sort of done its job in that the building hadn't collapsed, but it wasn't great, and the repairs were so crude there was no way that they could be left in place. So the only thing we could do was to actually dismantle the whole conservatory and replace the columns. Now, the benefit of this was that it meant that we could take look at every single piece of metalwork in detail. The glazing was removed first of all, and the contractor then tagged and labelled every single individual member. It was then all dismantled, taken to their workshop, which was nice and close by, actually in Barnsley. And then it was all blast cleaned, and it was absolutely beautiful. It took it back to showing some of the details of the original castings, which had been lost under decades and decades of paintwork. We then had new columns cast, and this is a visit to the foundry. Everything else is so modern. The casting process really hasn't changed. The only thing that was modern about this process was how they worked out the composition of the cast iron to use. But you can see them on the left-hand photograph as they were closing down the mould. They've got the two parts of the mould, closing it down, ready to pour the molten iron in that you see in the right-hand photograph. We made two interventions with the new columns. Normally, we tried to leave as much of the original fabric as it was, and any bits that you replace, you try to leave them as close to the original as you can. But there were two things that we did to try and increase the longevity of these. The first was to put a rodding eye in, so that in the future, the columns can be cleaned out. Any debris that gets collected in there can be rodded out. Secondly, we coated the interior of the columns with a bituminous paint to, again, give them more protection against corrosion. The reconstruction of the roof also allowed for proper access to allow the gutters to be safely cleaned. And that was an area where we had to think about doing it to modern standards of safety, not as the Victorians would have done, perhaps sending a boy up there in a very unsafe condition. And obviously it wasn't safe. They didn't do it, and it caused the problems that we now dealt with. The other area that had failed, as I mentioned before, was the gutter. Now, what you see here is a photograph of the internal cornice and the gutter. I'm going to bring up the next slide because it helps it explain a bit more. With the photograph there, you're looking from the inside, and you can see the wiggly shape of the internal cornice. That was in cast iron. There was then the hollow section, and then you have the U-shaped gutter, which was also in cast iron. We did some analysis of the existing sections and found that they actually didn't have the capacity to take the wind loads that were transferred to them from the glazed panels. So what we did was the cornice where it needed to be replaced, the sections that were missing or fractured from that, they were replaced using cast iron again. The gutter, we used a ductile iron, again cast, but using a ductile iron to give it some additional strength. And then the box section, that was done in stainless steel. And that's where the bulk of the strength for this new assembly came from. We inspected the cleat details where the roof glazing bars attached to the gutter and the ring beam. You can just about see one of the connections in that photograph. But where the glazing bars attached, a number of them had fractured. So we examined them carefully to see whether it was a case that they had corroded and failed due to lack of maintenance and by corrosion, or whether it was an original design defect. What we found was that it was actually a design defect because it was a repeating mode of failure that occurred. And so we actually reformed the ends of those members, and where necessary, we again used some ductile iron. Now, by calculation, we worked out that the conservatory should be quite unstable, and we realised that it depended on the stone wall at the rear to give it its stability. As we'd anticipated, the structure was really quite flexible as it was reconstructed until the glass was added in. This is the building once it was finished. You can just about see, I'm not sure how good the quality of the picture you're seeing is, but at the left-hand side, you can see the stone wall, which is actually what takes or provides the lateral stability for the structure. The wall panels, the glazing panels, a number of them had been replaced originally. They'd obviously bowed inwards with the original wrought iron framing. And as a consequence, a number of them had been replaced in steel. Now, of course, the steel then corroded, and so that had also failed. Historic England were very happy for us to get rid of the steel structure, but they did want the new structure to go back looking as much like the original as possible. And again, that postcard was very valuable in showing us how it had originally been. Now, you can just about see on this picture that there's, on the right-hand side, there's a window that's open, a vertical window that's open. And on the left-hand side, there's another vertical window, which is actually closed in this shot. The vertical glazing bars to either side of those windows were enhanced when we made the new frames. The original frames had been pin jointed, and with the wind load, they just weren't adequate for the job. We got agreement from Historic England that we could increase the size of those two vertical bars and braze the whole frame so that it became a grillage that would provide sufficient resistance to wind loads. Now, there was one other aspect of the new design, or bringing it up to the current standard, where I had to draw a line and say no. That was when they requested, this is a building services engineers, wanted the glazing to be upgraded to prevent heat loss. Ideally, they would have liked double glazing, but the potential consequence of that would have been that snow would have built up in the valleys. And there was absolutely no way that we could convince ourselves from the calculations that we'd undertaken that the structure would be able to sustain that additional load. And I'm actually quite embarrassed to say this, but bear in mind, I would remind you here, this was approximately 14 years ago. And I had to say that what they needed to do was keep the building heated, which they needed to do anyway because the planting that was going in there, it was temperate zone plants, which needed the warmth that wouldn't be available in Yorkshire in the winter. So they needed to keep the building heated, and the secondary result of that would be that it would help melt any snow that did settle in the valley. It's totally contrary to what we'd say now if we were asked the same question. And I do think every now and then as to how we would have dealt with that had we been asked that on a project now. That's the building from the front, and it's quite stunning. One of the things that you do see on this is the cresting along the ridge, which was missing when we came to see it originally. But we knew from the postcard that it had been there. And from that, from what we could see on the postcard, and we knew the foundry that it had come from originally, we went back to them. They had their pattern books, and from that we could work out between two different ones that it was going to be one of those two, and this is by far the more probable. So I'm going to take you on to quite a different project now, and this was a fire damage one. Again, it's in the Manchester area, Wythenshawe Hall. It's a Tudor timber framed building, which you can see the timbered part of it. Now, in fact, that timbering is, most of that's actually, dare I say it, it's fake. It's planted on the outside. The Victorians rather like to make buildings look how they thought they should do, more picture book than they necessarily would have been originally. But anyway, it started off as that C-shaped building with, you can see the timbering on, and then the other parts expanded over the years. This again, it's a Grade 2 star listed building, and it dates from the 15th century. Unfortunately, one night in 2016, a very unhappy individual decided to set light to it. As a company, we were brought in because we do a lot of work for insurance companies on major and complex loss claims, and this was both major and complex. We were quite fortunate that at the time, so this is what I saw when I first arrived at the site, but one of the first things that we managed to do was get an archaeologist from Salford University onto the project, and they also had a team who did cloud point surveys. So that work started very, very early on. Unfortunately, they took rather a long time to get the cloud point surveys through to us, but as soon as we got those, I went through the whole of this building. I say the whole of the building, it was the roof. The fire had been set in the porch at ground level. It had risen vertically up through the porch and then out along the roof structure, and it had taken out the roof, as you'll see later. So I went through the whole of the roof, looking at the condition of the timber, looking at each member in turn to see whether it was possible to reuse it. One of the first things, you can see the charring on these pictures. That is actually quite thin, certainly no more than 10 millimeters, and often less than that. And you lose quite a small amount of the timber. This was oak, and oak forms, as it were, its own fire protection with that charring. And it takes quite a lot of heat to actually burn through these more substantial oak members. So it was a case of going through, and again, I got my coloured pens out and worked out to mark up which were going to be the members we could keep. I'm going to just jump to show you, so you see the two pictures next to each other. The first one you're seeing at the moment is as it was when we first went in there. So just keep that in your mind a moment, and what you're going to see now is what it was like when we finished. So obviously the light coloured timber is the new oak that was spliced into the fire damaged. So I've been over the entire roof structure, working out whether there was sufficient section left on the oak members to be reused and just repaired. We had some interesting conundrums really with how to deal with some of this, because if you wanted to do a proper timber repair, these scarf joints that you're seeing up at the top, up towards the ridge of the truss, they would have needed to be much longer. But you've then got the incoming purlins, and then you had notches and pockets and so forth, and you actually couldn't get enough good timber for such a long way down the rafters of the trusses that we were going to lose a huge amount of the original fabric. So what we did was to do a compromise, and we did a combination. So on one side you'd have a steel plate, and it would be a bit of a hybrid connection between a steel plate and a timber connection. Bit unorthodox, but it worked quite well in this situation. Now, the difference between this project and the conservatory I showed you just now is how we've moved on in technology in this intervening 10 or so years. And what we had with the cloud point survey was we had a model of the whole of the building. So with my coloured pencils, I worked out the members in red, which had either been completely destroyed by the fire or was so badly damaged that we just couldn't do anything with them. And the green was what we're going to put in new. We took it into 3 dimensions, and this was absolutely brilliant because it was quite a complex roof, quite a complex building. And when we had to present to the client and to Historic England, they could really understand what was going on with this building. Now, what you notice actually, if you look at this, is the Cromwell room up towards the top of the drawing is all red. And that's because that roof had long since been removed. You may just about be able to see a grey cross underneath it. Those were oak, and they actually survived the fire. Those cross beams across the room survived the fire, but the softwood roof didn't. You also see on there the bell tower, and one of the first things we actually had to do was to lift that bell tower off. You can see from the braced structure, it had previously been taken off and re-supported. Presumably its original timber structure had failed long ago. I think it was back in the 1950s when they did some substantial and, by our current methods of working on historic buildings, some very poor repairs. It was quite interesting though. We were fairly close to Manchester Airport, and to get a crane in that was big enough to lift that off, we had to get permission because of the height of the crane that's going to be required in close proximity to the airport. It was more of a problem when we put it back on again, because by then the roof structure had been repaired and we couldn't, originally we actually cut through those steel members so that we didn't have to lift it up, but it was all repaired on the ground and had to be lifted back in complete. Anyway, going back to the work that we did on it, the intention was that we kept as much of the original structure as we could. So the grey that you see on the drawing was the original timber members, and the green is the new, yellow is where we repaired. What we did was we put in a lot of green rafters, as you see there, and they went back of Douglas fir, which had the agreement of the conservation people. The way we were permitted to do that was that you may just about be able to see is alongside them you've actually still got the old original grey of the original oak rafters. A lot of those were of varying size. A number of them had been fire damaged and were not they didn't have adequate bearing remaining at their ends. But in order to keep the maximum amount of the original structure that we could, we left them in place and just put new timber in alongside. The biggest problem we had on this building was the north gable. This, on the drawing you're looking at there, you can see the porch towards the front, and actually the north gable is labelled on there. It's the end that you were looking at previously where it had burned out. And the problem was that one of the bodies who advised Historic England didn't agree with us that the only sensible thing to do with this was to completely demolish. Sorry, I'm not allowed to say demolish. Was to would have been to dismantle this gable. The timber was so badly burned, and in between it, in the gaps between the timber, you had lath and plaster. The timber of the laths was obviously on the inside of this gable, and the fire had burned it, and so we had plaster just sitting there. Amazingly, it hadn't crumbled, but with the heat, its chemical composition had changed, and it was extremely fragile. We stabilised it by resin fixing some carbon fibre rods onto the back, and that held it in place relative to the original timbers. We eventually gained permission to put a new oak frame in front. So what you see in the blue is the new oak frame, which exactly replicated the original frame that had been there. But what you also may notice is there is a timber post above that doorway, and somebody in their wisdom, I think it might have been the Georgians, had decided they wanted to link through from the original hall through into one of the new extensions. So they just cut off the post. Unfortunately, at this stage, the wall distorted and bellied inwards, so away from what we're seeing here on the screen. So we had an extremely distorted wall, very unstable with significantly charred timber, which this organisation insisted that we had to maintain in its distorted shape and to be re-supported. So we did that with this new blue oak frame. We did add in the green members because we realised there was no way that it made any sense whatsoever to put it back without taking the load down to a transfer structure. So we were given permission to put in the new post and purlin. It was while I was working on this project that I first met a rot hound. This was the delightful Sam. He is wearing his sight gear in this picture. He's got his sight boots on and his high vis, and he would pitter-patter around the building. We had timber floors. You can imagine the sound of a Labrador with little neoprene boots on, tap, tap, tapping around as he went. And you could hear him breathing. He was sort of panting, and then he'd suddenly stop. So the pitter-pat would stop and the heavy breathing of the Labrador would stop just for a moment, and he'd look, and then he'd just continue. And whenever he stopped, his handler would write something on his notepad, and they'd just continue. He never praised Sam, and we weren't even allowed to speak to Sam, let alone make a fuss of him, until he got his sight gear off or he was back in his car. But he was amazing. He could smell out dry rot. Because one of the consequences of putting a fire out is you get a lot of water in the building, and so you get the fungal growth occurring. And he was amazing. He really saved us having to do a lot of opening up. He'd also taught himself to smell wet rot. So that was also of great importance and of great use to us. So lovely picture of Sam. What I'm going to do, there's a bit more I could say, but you've probably heard enough of my voice for this evening. But the main thing throughout all of this is looking and listening and taking note of what's going on around you, taking note of experience of other people. So whether it was from the rot hound to the steel fixer, to other engineers, Historic England, whoever, it's working as a team and looking and listening and training yourself to look and listen. And I'll leave you with the final thought that is actually really that successful learning requires more listening than speaking. There's a takeaway thought for the evening. Thank you.